Oh, that's right. And then I do this, that. Cool. Okay, so what we're going to do is we're going to read the abacus. When we do it, we do 1, 2, 3, 4, and then after that we have 5. So notice we have 0. Ooh, didn't do that. Let's see. 0. When we do 0, we have 0. None of the beads are touching. That means that this is 0. So we have 1, 2, 3, 4. I hope that makes sense. So what's going to happen is when we read the abacus, hello everybody, hello. So what we're going to do is we're going to read the abacus. When we read the abacus, we're going to look at these beads. With these beads, we know we have 1, 2, 3, 4. Because we have 4, right? 0, 1, 2, 3, and then we have 4. Now, let's take a look. We have 1. And if we have 1, well, what happens? Well, what's after 4? After 4 is 5. Well, what's after 5? Well, if you notice, right, we have 6. See that there is a similarity when I do the 1, and then when I add the 5, I get 6. And then if I have 2, I have 2, and then I add the 5, I get 7. When I go to 3, right, we know that this is 3, then we have 8 when we add the 5. And then when we have 4 and we add the 9, now we have, 4 and then we add the 5, now we have 9. Make sense? Let me know if you have any questions. So what we're doing is reading out the abacus, and notice every column has a 9. So this is 9, 9, 9, 9, 9. All of these are 9s. When all the beads are touching, these are all now 9s. So just as we write it, it'd be like this. So what's after 9? Well, this is 9. After 9, we have 10. This would be 10. So 10 would be like this. So notice there's a 0 and a 1. 0 and a 1. That means that this is a place value. So we have a 0 and a 1, and we can do 11, 12, 13, 14. And then remember, when we do the 5, right, this is 15, and then we add the 1, right, this would be 16. And then after, this is 12. If we add the 5, this would be 17. If we have 13 and we add the 5, now we have 18. If we have 14, and we add the 5, now we have 19. Let me know if you have any comments or questions. Let me know if you have any questions. If you don't understand, let me know. And then we can reiterate how to read the abacus. So what we're doing is we're learning how to read the abacus and how it pertains to math. And so here is our place values. We have our 1s, our 10s, our 100s, our 1000s, and our 10,000s. As we look, we have our 1s, our 10s. So this is 20. And then now, if you look, this is 30. 30 looks very similar to 3. When we say this, right, this is 3. But then when we move it over, now we're at 30. And that's because we have our place values. We have our 1s, our 10s, our 100s, our 1000s, and our 10,000. Does that make sense? So let me know if you have any questions and I will answer them. So we have 30 and then we have 40. After 40 is 50. So when we do 10 and then we add the 5, now we have 60. If I do 20 and I add the 5, now we have 70. When I do 3 and I plus the 5, now we have 80. And then again, if we have 4 and then we add the 5, now we have 90. And I think this is a better way to talk about it. So now we have our 1s, our 10s, our 100s, our 1000s, our 10,000s. Let me know if you have any questions. So what's going to happen is after the 100s, after the 10s, we have our 100s. So remember, so if you look, this is 9. After 90 is 100. After 100, we have 100, 200, 300, 400, and 500. And so again, it's the same concept. We've seen this before. So if I made this, and then that, what number do you think this is? Please put in the comment what number you think this is. Thank you so much for the likes. Thank you, everybody. Welcome, welcome, welcome. So in the comment, what number do you think this is? So we have our 9, 5, 6, 7, 8, 9. We have 9,000. And then this one here is the 5. It's a 500. And then, oh, Raven, yes, exactly. 20, 1, 2, and then, no, not 3. Not 3. You know why? Because we have the 5 here. So it's 5, 6, 7, 8. Whoop, whoop. Yep. Good job, though. Hey, Dean, welcome back. So what we're doing is we are reading the abacus. When we read the abacus, yeah, it's interesting that the abacus, gives us the skill to attention for detail. Yes, hello, Dean. Hello. Oh, I was thinking about division and how to make it easier to explain. I made this little contraption. It's so funny. I made this little contraption to help me tell you guys what the dividend and the divisor. Do you like that? So we can do multiplication, addition, subtraction, multiplication, division. And so I was like, how do I make this? And I realized I can't throw away things because this was actually a plastic thing that was on my plastic marker container. And then I was like, I'm just going to throw it away. But then I realized I can use it. So I actually picked it out of the trash and I reused it. So I think this is going to help when we start doing division and we talk about the quotient and we talk about the dividend. And I think that's going to help a lot. So, but the first thing we're going to do is we're going to understand how to read the abacus. So, it is helpful for sure because addiction is confusing. Yeah, yeah, it is. Yeah, with the dividend and I didn't realize how difficult it is for you guys to visualize that. Yeah, I say at least it's resourceful. I try to be. I try to be. So the first thing we're going to do, yep, I understand. So the first thing we're going to do, Raven, did that make sense? You know what? Are we ready to do a maze? Hello. I don't know who else is here. Anybody else here? Do we still need to review? So what we're going to do is let's do a little review. When we do zero, abacus is a little bit addicting. So, sorry. Okay, so we do zero. We have zero. This is zero. Why? Because none of the beads are touching the horizontal bar. So this is what this is. This is zero. So then after zero is one. After one is two. And then we have three. So that's what three looks like. And then we have four. After four, we have five. If you notice, we have the five, which is the top bead. The top bead will always be five no matter what. Now when we look, we have five and then we have six. Now notice if I have one, right, looks very familiar. If I have one, well, that's not right. If I have one and then I add the five, it is now six. Now notice if I have the two, guess what? If I add the five, now we have seven. Let me see. Can I do this? Can I do this? Yeah. Let me do that. Okay, good. So, so then if we have three, when we have three, and I add the five, we have eight. And then if you notice, if I have four and I add the five, now I have nine. Anybody have any questions? Thank you so much for liking the live, but let me know if you have any questions. Like, I'm not sure where everybody's at. Does that make sense? Should I continue to do some number recognition? So we could do, what we could do is we could do this maze. So I have this maze. Why start there? Oh, that's a good question, Sarah. So the reason why is because I have this indicator. If you see it, I have a dot right here. This is my ones indicator. Yeah, so I have my ones indicator. So this is my ones. And when I look at it, I actually have decimals, like as if we were having money. So this would be where I can put my change. And so if you notice, I actually have another dot indicator here. This is my ones indicator. And so I can be like Pokemon, right? I could choose you. And Pokemon, they do some, they fight, right? You have to pick your Pokemon. So that would be what these are. So you could choose this one and then I would move everything over. But notice when I move everything over, I don't have any more hundreds. Ooh, I should do that lower. I don't have any more hundreds. Yeah, Pokemon. So notice that I have my ones, and then between the tenths and the ones is my decimal. So when I look at it, decimal does not have a place value. We have our tenths or our tenths or hundreds or thousands. And notice that these dots are grouping everything. So when they group, it's easier to label. When I choose this one, now it's easier to label my thousands. So I have my ones and my thousands. So what happens when I have more? Well, when I have more, like this one is a 13 column abacus, and there's, size matters. It just depends on what you're trying to do, how big the numbers are, how big your question is. So what it means is if I choose this one, I have my ones, thousands, and then millions. But then if I really wanted to, I could go all the way to here. And this will be my ones, thousands, millions, billions, and trillions. And that's what the indicators are for. The indicators are helping me to label and index, right, the different columns. Because if they weren't labeled, then we would have to you would have to count it out, right? But then if you're trying to track the national debt, you need a bigger abacus. This was 23 columns, and 23 columns is the same. It's just bigger. It's just more numbers. That's all it is. So again, we have the same concept. We have our ones, our ten, our ones, our thousands, our millions, our billions. But then if we wanted to, we could start from here, and then notice we have the 2 columns here, and that would be where our change is. Of course, not a problem. Thank you, Sarah, for the question. And so notice that this one is actually made out of, I don't know if you can tell, but this is made out of bamboo. This is made out of plastic, and this is also made out of plastic. Does it matter about the colors? It doesn't matter about the colors. What matters is the placement. So they work exactly the same. If I wanted to use this one here, I could use it. It'd be just the same thing. It'd be 1, 2, 3, 4. And then when we have the 4 and then the top beat comes down, this is 5. And then we have 6, 7, 8, 9. And then we have 10. Notice my 10 is next to the dot indicator, right? So this is my ones indicator. After the ones indicator, I have my hundreds, and then I have my thousands. So again, I have my different groupings. So that is a little bit about the abacus. Thank you so much for the question, Sarah. Yeah, some people don't understand. That's fine. Because nobody really knows how to really read the abacus. So thank you so much. My show's on. Yeah, Dulce, welcome back. So we're going back to here. The reason why I like to use this one is because it's pretty, right? We could, when we get to bigger numbers, we can start using this one. But for right now, we can use this one. So here, this one's a big one. Would it make it up to millions? It would make more than millions, actually, because we have our ones, our thousands, our millions, our billions, trillions, quadrillions, and quintillions, I think it is. I don't know what's after that. So yeah, the big one is 23 columns. Yep, cool. So we're going to continue on, and I'm not sure if Sarah's around, but what we're going to do is we're going to read this abacus. It's a little maze that I created so we can practice how to read the abacus. So let me know, what number do you think this is? If I showed you on the abacus what it looks like, this and then that. So let me know in the comment, what number do you think this is? And there we go. There we go. How about that? There we go. Yeah. So what number do you think this is? 61. Yes, Dolce. Yes, because we have 5 and then we have 6 and then this is 1. Dolce, she's only tutor. What? She's the only tutor that can teach and entertain. Thank you. I appreciate that, Dean. So here is 61. So I'm going to color in 61. And what we're doing is we are following a map. We're following a maze. And so what number is this? So we have this number and then this number. So if I color it, 1, 2, 3, and then 5, 6, 7, 8, 9. Okay, I wonder if Sarah's still around. Hey, Shad. Yep. Anybody there? Yeah, we're okay. We're okay. We understand. So, yes, Dean, 39. Okay, absolutely. Okay, good. Okay, so here's a question because it doesn't seem like Sarah's around. Do we want to do 3 digits? Oh, there you go. My brain just popped. Oh, hey, you're here still. Okay, we're gonna continue to do 2 digits then. So that's 39, and what we're going to do is we're going to color it in, and now we're up to this one. So, you mean to tell me I'm voluntary learning math? No, keep going. Okay, yes, 3 digits after, if that's okay. That's fine with me. I actually have a 4-digit one too, but I didn't print it out. And then I forgot, and then I didn't print out my reverse one, but I don't think I could do the reverse one with you guys. So, she's the only reason I'm learning abacus. All right, you guys, I teach preschool. Hey, that's cool. You can, oh, you know what, Sarah? Whoop, whoop. Sarah, guess what I got? I actually got worksheets that you can use if you wanted to. And then what it is what we're doing is we're doing a bead recognition. Oh, no, 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 go. I don't know what you just said. So so this one is about bead recognition, and there's like activities and stuff, and it's about number and bead recognition, and then understanding how to match the beads with the numbers. So that's what's available. We could talk about that later. But I've been seeing the kids doing the finger like fast math, and now I'm obsessed. Yeah, yeah. There's this one kid. His name is he has the world record for doing 104-digit numbers in 30.9 seconds. His name is Arian Shulka. Yeah. And it was really interesting. Keep going, do your thing. Okay, not a problem. Not a problem. Okay. So what number do we have this? Yeah, it was pretty amazing. And he was able to get all the numbers. And it's like, I can't even see all those numbers because all those numbers flash. And so it was really interesting. 39 seconds. It takes me a while to just even look at the numbers. So it's fascinating that they can remember the abacus in their heads. It is very fascinating. And I think obviously it's about practice, right? But I'm not here to push it. I'm just here to help minimize the mental strain. What is it? I read it minimizes mental labor. That's what I like the abacus. The abacus minimizes the mental labor. So if I have this number and then that number, what number do we think this is? Yeah. Hey, XD, welcome. And then I don't know who else is here. But if you have anybody have any questions, let me know. Let me know. 51. Thank you, Dean. 51. How about you? Oh, Violet. Yes. Sarah, almost. So what we're going to do is we're going to readjust. We're going to do the 5. So the 5 will always be the top bead, and then the 1. You have the 1, but the 5 is always going to be the top bead. When we do 4, this is 40. This is 1, 2, 3, 4, and then 5 will be the top bead. Yeah? So we have that, and we're going to follow the maze. And now we have this one. So we're up to here. If I have this, and then these, right? I have this. Oh, that doesn't make sense. That, and then that. Yeah. Cool, Violet. Welcome back. Okay. Oh, Joe loves 80s. I love 80s too. I love 80s. I like Howard Jones. Thank you, Violet. Cat. I should call you Cat. Yes, thank you. I know I'm trying to stunt on the haters by knowing how to use an abacus. Yes, exactly, Kat. That is exactly what it is. It is 64. So 64, yes. So we're going to do 64, and then we're going to go to the next one. So hopefully this makes sense. And what we're doing is we're just doing a maze, and we're just following the abacus. And so if I had one like that, that's what that is. Cool. Yes. Awesome. So yes, it is. It is 3. Good, 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 good. So what number is that? Oh, maybe I should bring it down a little bit. Yeah. I do like this Mask of the Maze. That was a really pretty cool thing. So if I do this, 5, and then 5, so then we have this. Haters don't even know what an abacus is. Yeah, that's very true. That's very true. 99. Yes, thank you, Dolce. Thank you. Yeah. Nice. So that is 99. Okay. And then we do that one. Yeah. They get confused. The haters get confused easily, and they're not understanding the benefits. I mean, there's benefits to all sorts of ways to do all sorts of ways to do math. I'm not saying this is the only way. I'm saying that this is one of the benefits. This is the benefits. They can't even spell out. They don't, honestly, they don't even know how to say it, which is interesting. They don't even know how to say it. Oh, I gotta do that one. There we go. Yeah, 91. Cool, cool. 91 goes this way. So we have this. And then we have that and that. So if I did this, and then that. Yeah, thank you so much for the follow, Sarah. Anybody have any questions? Jason, you just came in. Do you have any questions? I think Kat left. Did Kat leave? Oh, no. I used to think it was abacus too. I don't know if Kat left. Ah, said Panda. Hello, ma'am. I'm here. Oh, good, Kat. You're still here. Okay, good. I wasn't sure. Are you understanding what the numbers are? Are you understanding how to read the abacus? If not, let me know. We can review it. Okay, what number do we think this is? 75. 75. 75. Because we have 5, 6, 7, and then the top bead will always be 5. So this top bead will always be 5. So this is 75. That is correct. Sarah, does that make sense? When we do the 5, the 5 is the top bead. The top bead will always be the value of 5. So when we look, we have our 5, and then we have 1, 2, 3, 4. There we go. Great. What number do we think this is? 54. Yes, 54, because we have a 5, and then we have 1, 2, 3, 4. Does that make sense, Sarah? So what we're doing is we're just learning to read the abacus, and this is just coloring. Now I'm just coloring. So when we look, we have this one. And if we see it, we have this, and then we have that. So we have this, and then we have that. 25. Thank you, Dolce. Thank you. Whoop, whoop. All right. So we have 25, and then we go this way. Yeah, I'm actually quite excited to go back into division. But I think I figured out an easier way to explain division. So we have this one. We have our number, that. So if I did this, and then that. I've always wanted to learn how to use the abacus. Oh, really, Kat? That's really interesting. How do you do division on that? Yeah, we can do division. We can do division. It just depends on how quickly we can do it. But yeah, we can do division, multiplication and division on the abacus. And I think, honestly, when I started comparing, it's actually a lot easier to do division on the abacus. Yeah, I think it's easier. I mean, there's a little bit of extra steps. But I think it's easier when you understand the extra steps. I think it's easier to do division on the abacus. Yes, Dolce. Last one. We got this one. This is the last one. Division seems so much harder than any form of math. Yes, and I think it's because they group it too big. But I'll show you on the abacus how easy it is. And what it does is on the abacus we break it up into smaller chunks, and it makes it really easy. And I don't know why we don't do it in the first place. So, but yeah, abacus helps break it up a little bit, but there's a little bit more steps to it. So last one. What number do we think this is? And then we can do 3 digits. Whoop, whoop, 3 digits. Okay, 42. Yeah, right? Because that's the answer to the universe. I don't know if you guys, oh, thank you. Thank you, Crazy, and thank you, Kat. Yeah. Welcome. Let me know if you guys have any questions about how to read the abacus, because what we're doing is we're learning how to read the abacus. Curious, I'm used to seeing the abacus with 10 dots and counters. That is a different abacus, yes. And, if you have the 10 bead one, you can do multiplication. So if you have one of those, which is good too, you can actually modify it. I don't know if you have that in your school, but it is a 10 bead, and the 10 bead doesn't work the same, but you would have to modify it. So let's say this is my 10 bead because I don't have one. let's say this is our 10 bead. So what I would do is I would tape 5 here, 1, 2, 3, 4, 5. I tape it, and then I would leave these ones by itself. And so what you could do is you could now flip it. So I mean, if you had more, right, you would have more. I tape more. I tape each column, right? I tape each column. 1, 2, 3, 4, 5. That's what I would do, right? And then after that, oh no, right? After that, I would do is I would flip it, and I would go like this. Does that make sense? So when you flip it, now we have different place. Now we have the same place values. And I would just choose any column. I would probably choose the third column because then you can do money somewhere in the closet. Yeah, right. So what I would do is I'd do the third column. So I'd have 3, right? 1, 2, 3. And then I'd use, because you would have more. I just didn't tape it all. So then what I could do is I would do that. So then I would have a string. I'd have a string, and then this would be my reckoning bar, just as I would have on my abacus. So it's kind of nice because I actually do like this because then the kids can see the amount here, right? So this is 5, so they know that this is 5. Sometimes they don't understand, but they understand. Oh, good evening, Ashley. So then what I would do is, and it would be the same thing. If I want to add the 5, right? If I add the 5, then I just bring down to touch the string, right? If I wanted to add 6, I would bring up the bead. And then if I add 7, right? Then I bring up the bead. Yeah. Yeah. Now I get it. Yeah. So I would modify the 10 bead just so it mimics the soroban. This is what we call a soroban. It's a Japanese version. It's a Japanese version of the abacus. It's called a soroban. And if you wanted to, you can buy it. But if you have the 10 bead one, you can modify it. Right? So it's called a soroban. Soroban. That's a Japanese abacus. Yeah, a big visual. Yeah. Yeah. And so that was the one thing, like I'm really big on showing and not talking. So that's what I would do. And then if you have 3, so it makes sense because you have 5, right? But then if you want to remove it, right, you move it up. But you would have to lie it down. You have to lie it down flat. Yeah, I don't know if there's a problem with an angle on it. Yeah, no, thank you, Sarah. Thank you for asking. Because, people just don't know, right? So, but yeah, that's what I would do. That's what I would do. I wouldn't buy an abacus if you have the 10 bead one. The 10 bead one is nice because it's a one-to-one relationship, but when we get into adding and subtracting, we're going to start going into critical thinking and analytical thinking, and that's when we start talking about using formulas and using addition sentences. So that's probably why I would actually recommend to convert your 10 bead into the soroban the way. Yeah. So that's what I would do. That's what I would do. I wouldn't buy. I I'm more resourceful. I would rather just use what I got. So if you can use what you got, I would rather do that. Yeah. And then, have the kids start counting and stuff. But yeah, that's what I would do. Okay, so I see the Amazon is almost all the black beads with a few red beads. Do you know why? Yeah. So the ones with the red beads, let's see, the ones with the red beads is like your indicator. If you notice that there's the black, and then if you notice every grouping has the indicator, and that would be a red. So there'll be a red here, and there'll be a red here. So if you notice, they'll be grouped of 4, 3. So your ones, your tens, your hundreds, your thousands. That's why. That's why there would be that's in, to each their own. You can have that. It's cool. Fun finding you. Love it. Thanks for explaining. Yeah, not a problem. Not a problem. Kat, did that make sense? So if you notice, every red bead sits on a group separator. Is that what it's called? A group separator. Yeah, that's why. And I like it. I mean, I don't need to buy any more abacus, but it's good. It works exactly the same. It works exactly the same because you still have the top bead and you still have the bottom bead. Yeah. And if you notice, there's still 1 bead on top and 1 bead on the bottom. 4 beads on the bottom. I don't think you're going to see too many with 2 beads on top and 5 beads on the bottom. This is more now like now this is more like in the museums and stuff. Yeah, not a problem, Kat. So this is a Chinese abacus. I don't know if anybody has a Chinese abacus, but it works almost the same. It's just the problem is now there's a little bit of redundancy. Why? Because when we count, we still do 1, 2, 3, 4. So we look, we have 1, 2, 3, 4, and then 5. So this will always be 5. Well, if we look at it, we got to do a trade because this is 5. We can do a trade. That's 5. So now it looks kind of like the Soroban. So when we look, we have 6, 7, 8, 9, and we have 6, 7, 8, 9. But then when we do 5, we have to do another trade. When we do another trade, it's this 5 that goes up here. And this breaks my brain because this doesn't make sense to me. Because now we're no longer using the columns as a place value. We're just using columns just because it's there. So then you'd have to do another trade from here to here. So now it makes sense. So now we have 10 because this would be a 0 and this would be a 1. And then if we look at it, this would be 10. And that breaks my brain too. That's too much thinking. So there's a lot of trading in the Chinese abacus that is a little redundant. So Japanese came around and said, you know what? We can make it more efficient because that's what they do. They make everything more efficient. So this is what the rest of the world is using now is the 4 and 1. There you still know some people that use the 2 and 5, but most of it is now a 1 and 4. All right, so that is that. All right, and then we're gonna do 3 digit. Let's do 3 digits. Okay, so again 3 digits, and we're gonna have to find this. Oh, that's not good. There we go. We're gonna have to find the start here. So wait, what are we doing? Wait, does the second top not allow to be the line if the bottom 5 are? No, it's still the same. It's all still the same. So it actually doesn't matter. You can get 15. So here we have this. We get 15. But now it's really breaking my brain because this is hard to see. Yeah. Thank you for explaining it. That's smart. Thank you. Top bead. Yeah. So the second top bead, it's still 10. So when we do 10, right, we can still do a trade-in. So, but now this is 15. I'm like, that's too much thinking, right? So that's why we would trade it into this. So this would be the 15 that I would recognize. But then I take that back. I would actually do this would be my 15. So it's a little bit of redundant. Yeah, it makes sense why it's confusing. Yeah. And it's harder to be really quick if you have too many ways to do things. That's why when the Japanese did it, it's this is one way and one way only. So you don't get confused. Yeah, maybe. I'm different. I think it kind of make more sense to me. There are some people that do like the Chinese abacus, and so it is available to you. The questions, the formulas are still the same. You would still need to know to do the formulas. So if we did 4 and I need to add another 4, you still need to plus the 5 minus the 1. You still need to do that. So it's not like it's completely off. It's just not as efficient when you start going through 5. And 5, and you have to trade it in. But there are people that do enjoy the Chinese abacus more than the Japanese one, and it's fine. You can do that too. There's no right or wrong. There's the options, right? So when you look, yeah, it's that's what I've noticed is the formulas are still very similar. So fantastic Mr. Fox movie reference if you've seen it. What? Mr. Fox movie. I will have to go take a look. Is it the abacus? The Chinese one? Oh, I found SpongeBob. Beatrice, I think, was doing the abacus. It's a stop motion movie. Oh, that's interesting. Okay. And he's using the abacus? That's interesting. Okay, yeah. So I've been trying to collect all of my places where I see the abacus. Yeah, so somebody mentioned about SpongeBob, so I got that one, and then I went to go look at Fairy Mary because she's using the abacus. References. Oh, what don't you say? Okay. So I gotta rewatch it now. Yeah, I will. Is it called Mr. Fox? And then where can I find it? Where can I find Mr. Fox? It's a son of a movie. Fantastic Mr. Fox. Okay. Okay. I will take a look. I enjoy movies too. Okay. So we have this. Now we're dealing with 3 digits. Now we're dealing with 3 digits. And what do we see? What do we see? With our 3 digits, we have our this one, and then that. I think Hulu, if I remember. Okay, I will take a look. Mr. Fox, Fantastic Mr. Fox. Okay, so it's 5, 6, 7, 8, 5, 6, 7, 8, and 1, 2, 3. Yep, 883. So what we're going to do is we're going to do 883. And now we have this one. Oh, if I bring it down, there we go. So now we have 3 digits. So if I do that, and then that. There we go. We have that, and then this. Woo! Cat's on a roll. 357. Yes, thank you. 357. Okay, so we have this one. We have that. So what are we doing? We do this, that, and that. There we go. I wish my exposure would be like that, but I know it doesn't. Yes, 8, 5, 6, 7, 8, and we have 6, 5, 6, and 2, 1, 2. So we have 862, and then we're up to here. So this one, and that. Thank you, Dolce. Yes, 700. Yes, 5, 6, 7, and then 80. 5, 6, 7, 8, and a 0. Hello, Michael. Welcome. So we have 780. Now we have this. What we're doing is we're trying to read the abacus. And after we read the abacus, we're going to go into adding and subtracting. So I have this number with that. Uh-oh. Yeah? We're okay? Okay, cool. 7. Will we do multiplication and division today? I think we can. Dean 6, 5, 6, and then 10. Yeah, I think if the class is small and we go pretty fast, we can get into division. It just depends on how quickly we can get through the adding and subtracting. You know what I mean? Multiplication is pretty easy. Division takes a little bit. So if I did this and then that, so yeah. I hope multiplication is top tier. 500, 400, 1, 2, 3, 4, 5, 50, 1, 2, 5, 6, 7, 8, 9. Yes, 459. Yes, thank you, Kat. And then 459, we're here, and then we're here. Oh, we have this one, that one, this one. Well, after this, we can go into adding and subtracting, and then after that, we can do division or multiplication. Yeah. No, after this, yeah. So 9, 5, 6, 7, 8, 9, 50, and then 5, 6, 7, 8. Yeah. Nice. Okay. Cool. And then we have this one. Yeah, I think doing a maze kind of helps get everybody understanding how to read the abacus. And then after that, we can start doing adding. And then after adding, we do subtraction, and then we can go into multiplication and division. And multiplication's, yeah, pretty easy. So we have this 1, 2, 3, and then 5, 6. Yes, thank you, Dolce. 307. And then 307, and then we have this. Thank you so much for the likes. So we have that number, this, that, and then this. There we go. Yeah. Yeah. Dolce answers so quickly, I can't keep up. You guys. 1, 2, 3, 4, and then 50, and then 2. We have this, and now we're here. I'm sorry, I'm having fun. You guys are so cute. Funny, you guys are so, I love you guys. So funny. Okay. What is it? Somebody said that they felt like that they were FaceTiming each other. Oh, sorry. 5, 6, 7, 8, 9. Sarah, let me know if you have any questions. I totally got scared. No, it's totally good. I was scared to answer too early. Oh, I think Sarah left. What number do we have that? $195. Sarah, it's forever in our memory. Yeah. Okay, 2 more and then we're done. 2 more and then we're done. So if I did this one, it would be this and then that. Hello, Blue Raptor. Welcome back. 86. Yes, it is. 5, 6, 7, 8, and then 5, 6. Yes. 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 And final one. This is our last one. What number do we think this is? And then, that's interesting. Okay. I am back. All right. Last one. 1, 2, 3, 4. And then I think it might be lagging for a second. Yeah. Yeah. I think so too. I see it. 407. Yes. No, not 7. 6. Yes, Kat. Thank you. 6. 5, 6. Okay, that's it. That's it. Okay, so let's do a little bit of adding and subtracting. So what we're going to do is we're going to move the beads. When we move the beads, what does that mean? We got to understand how to move the beads. We understand how to read the abacus. Now we got to learn how to move the beads. The reason why is because that's just part of adding. And you'll notice that when we start going through it, in school, we are always learning the result. But in abacus, yeah, I was lagging too. I think it was TikTok. So what's going to happen is in abacus, we actually focus on the add-in. So if we look at 1, we're going to add the 1. What that means is if I have 5, when I have 5, I'm going to add the 1. When I add the 1, I just want to move the 1 bead. So that's all I'm doing. I'm going to move the 1 bead. And notice it doesn't matter what bead I'm moving. I'm just going to move the 1 bead. So if I move this bead, it doesn't matter what color, as long as I move 1 bead. And that's the idea. The idea is to understand how to use the add-in. Right? So then we would do minus the 1. When we do 1, we want to do 2. And again, if I have 5, right? I have 5, and then I want to add 2. Again, I'm adding the 2 beads. But notice I'm going to the horizontal bar. what I'm going to do is I want to subtract. I want to take away from the horizontal bar. I want to move it away from the horizontal bar. Does that make sense? Cat, because Dean and Dolce have been around, so now I'm only talking to Cat. And I don't know if Jason's around, but and I know Ashley knows this. That's it. That's everybody in my room. So I'm not picking on you. I'm just making sure you understand. So when we do it, we want to go to the horizontal bar, and we want to move, and when we subtract, we want to go away from the horizontal bar. So it's the same thing with the 3, right? When we do the 3, like we have 9. No, we have 6. If we have 6 and I want to add the 3, I'm going to go to the horizontal bar, and then when I subtract, I want to go away from the horizontal bar. So as we know how to add, and then after we know how to add, we will know how to subtract. So this one is kind of easy because the 4 doesn't have a lot of numbers. It's always just going to be the 4 beats. So either it's 0 plus 4, or it's going to be 5 plus 4. And this is what we call simple. The reason why we call it simple is because there's it's not necessary to use a formula. And I put it in quotes because we'll get there after we understand how to move the beads as a simple thing. So the biggest question is like Bob the Builder. Can we do it? Yes, we can. So after 4, we do the minus, and then it's the same thing. We know we have to take it away from the horizontal bar. So this is the horizontal bar. Sometimes they call it the reckoning bar. Sometimes they call it the beam. Sometimes they call it, I don't know. Some people call the beads heaven beads and then earth beads. That's a lot of woo-woo for me. It's just the top bead and the bottom beads. I didn't want to be woo-woo. So this is 4, and again, 4 is take away the 4. When we take away the 4, we're just moving it away from the horizontal bar. Now after 4, we have the 5. It's the same thing, but now we're going to the horizontal bar. We have to bring it down, right? Because it's a top bead, we come down. So that means this is adding the 5, and subtracting the 5 just means moving it away. So when we add it, we subtract. And it's the same thing with the 6. We add the 6, and we take away the 6. Hey, Nian. So when we look, again, you'll notice that if I want to add the 5, I could take away the 5 by removing it away. I'm taking it away from it, right? I'm minusing the 5. When I want to add the 6, I'm bringing it together. When I have this, right, 7, and I want to take away the 6, notice I push it apart like this. Hey, Mel, welcome back. So what I'm doing is I'm showing how to move the beads, and that's what it is. All it is just moving the beads. When I do 8, you bring it together at the same time, and I use the index finger and the thumb, and I bring it together. When I subtract, I'm going to subtract 7 from 8. All I got to do is move the beads like this. So it's simple to understand for right now, right? And is it complicated? It's not complicated. It's easy to use and simple to use and easy to understand. And so that's it. So 9, right? We know what 9 is, and then we know how to take away the 9. So the closer to the bar is adding exactly. So you go to the bar is adding, away from the bar is subtracting. Exactly. And so that's it. That is all about adding, subtracting, but that's what we call simple. Now what's going to happen is, what happens if we don't have enough beads? What do you mean? Well, one of the things is, if we don't have enough beads, so here's a question that we have. And one of the questions is, let's do this one, 2 plus 4. Now, we already know what 2 plus 4 is. Well, yeah, we actually had to memorize this in school, right? So it's different. I'm not trying to memorize random numbers. What I want to memorize is a concept. So there's a concept that we're teaching the kids. What are we teaching the kids? We're teaching kids how to make a 5. But that's as far as it goes. So now what are we doing with this? Well, in abacus, we actually level this up. We actually level up this concept. Now, not a lot, but those people that are confused are like, you're making it more complicated than it really is. I'm like, no, it's complicated to memorize, but now we're going to do a concept. The reason why we're going to use this concept is because we want to add the 4. When we add the 4, you'll notice the abacus has restrictions. Because the abacus has restrictions, we now know how to work with it. We know how to work with restrictions. So what's going to happen is, I have my concept. I want to have a 4. Because I have 4 and I don't have enough beads to add the 4, I'm going to use this concept that we're already teaching the kids. And it's adding the 4 is equal to 5. But notice what I'm going to do is I'm going to isolate the variable. Now we're getting into a little bit about algebra. So if you notice, we do this is algebra. right? When we do a little bit about algebra, this is the stepping stones. This is the foundational stuff. So when we look at it, we want to do 4 is equal to 5. Because 4 is equal to 5, that's not balanced. That's not what the equation is, right? So what we need to do is we need to minus the 1. Now we have directions. What? What do you mean directions? Notice, if I want to add the 4, all I have to do is add the 5 and take away the 1. This is why we need to know how to subtract. We don't just subtract just willy-nilly. We need to understand, oh yeah, remember this. Yeah, right? So now we have this concept and we can make it better. We can make it more versatile. We don't need to memorize our doubles. What we do need to memorize is our formula. So when we do the formula, we have 3. When we have 3, I want to add the 4. Again, there is a bunch of things to do with 4, not a problem. But in abacus, what we do is we plus the 5 and we take away the 1. And my final answer is 7. Right? So now we're doing this again, right? We do 4 plus 4. Again, we don't memorize. We do not memorize doubles because it's useless. You can only do doubles once. Whereas if you memorize the formula, if you memorize this concept, now it's versatile. Now you'll be able to do actually any question. Well, roughly, right? So we have our 4. When we add the 4, I want to add another 4. To add another 4, what do? I need to plus the 5 and take away the 1. Does that make sense, Kat? Thank you for the likes. Welcome, 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 everybody. Let me know if you have any questions. Let me know if you need to do a little review on how to read the abacus, because we're moving on to more addition. So, is Kat, you okay? Thank you so much, Maddie Moose. Do you guys have any questions? Those that just came in? I think I need more examples. I'm a little confused. Okay, not a problem. Not a problem. So the one thing that we need to do is understand that we do not want to look at the answer. We want to look at the question. So when we look at it, what we want to do is look at the abacus. If I'm adding the 4, if I add the 1 and I want to add 4, my question is do I have enough beads to add the 4? No, I don't have any more beads to add the 4. I only have 3 beads. So what we're going to do is we're going to utilize this 5. Because we have this 5, we have this extra thing up here. But if we add the 5, it's too much. So we need to move the 5. We need to add the 5, but that's too much because we only want to add the 4. So now what we want to do is we want to balance, right? We want to balance the equation. Let's see if this helps. So I have money. I have a nickel. And I have 4 pennies. I want to give you another 4 pennies, but I don't have enough. I only have 1 nickel. Because I only have 1 nickel, I want to give to you, but you can only have 8. So to make 8, and I only have 1 nickel, I'm going to give you my nickel, but you have to give me my change back. So you have to give me back 1 penny. Does that make sense? So now we have 8. Okay, so it's kind of the same thing. So she has a lot of examples to help. She has a lot of examples to help with commutative property. Yeah. So here I have my 3, right? If I have 3 and I want to add 1, I want to add 4, but I only have a nickel. You ate that reference. Yes, I get it. Yeah. So I only have a nickel to give you, but I want 4, right? I need to get 7. But to get 7, I can give you my nickel, but you need to give me back a penny. Sequel nickel. I don't know what that means, Mimi. Sorry. Oh, a nickel is 5 cents? A nickel is 5 cents? So that's why we have this, right? So this is 5, this is a 5. So if this is 5, this is 6. Because this is 6, this is 7. So this is a nickel. Nickel is a 5. And a penny is 1. Yeah, yeah. So here, it's 1 cent. So when we're looking at it, this would be 9, 5, 6, 7, 8, 9. This would be 9, 5, 6, 7, 8, 9. And then when I want to look at it, I want to add the 4, right? I'm adding 4, but I want to add another 4. But to add another 4, I only have this nickel. I only have 5 cents. So what's going to happen is I'm going to give you 5 cents, but you have to give me change. And when you give me change, I'm going to take away the 1. So that's what we did for that. Yeah, thank you, Mimi. Let me know if you have any questions. If you need to, we can review how to read the abacus. Let me know. So that's what it is. So it's the same thing. It's the same thing with the 3. Now, how do I know? Well, there is more pairs. So now what we can do is we can solidify our understanding, right? We could do the 3. The 3 plus 2 equals to 5. What? Really? Yeah. And it's the same thing, but different numbers. Because the thing is we're now learning our pairs. When we learn our pairs, right, 2 is our pair. So what's going to happen is if I did 3 plus 3, I don't want to memorize doubles. What I want to memorize is a concept. So this concept is 3 plus 3. Well, no, not 3 plus 3. So if I have 3, I want to add another 3. I cannot add a 3 because I don't have any more beads. So what do? I have this concept. Plus 3 plus 2 equals 5. I'm going to isolate the variable. I'm going to make it by itself. When I make it by itself, I want to add the 2. No, I want to subtract the 2. Oh, I'm doing the wrong one. So, sorry, I'm in the wrong one. So it's actually 3 equals 5. This is not balanced. So we need to balance it. We minus the 2. So what's going to happen is, if I look, I'm going to add the 5, and I'm going to get 2 take away. It's the same thing with the money. If I have 3, and I only have a nickel, and I'm going to give you 3 from this nickel, I'm going to give you the nickel, and I'm going to take away the 2 beads, the 2 pennies, the 2 cents. So because I take away 2 cents, you are left with 6, and I take my money back. Yeah. So this is a concept. So this is the concept. And what we're trying to do is we're trying to utilize this information. Oh, I think I really see how to do it on the abacus now. Yeah. So that's the one thing. And that's why I kind of like having the different, the big blocks too. But that's the thing, right? It was one of these where this is 5. And so if I give you 5, I need something back. So we can't break it up. But in order to replace it, yeah, sorry, I just confused everybody. That's what, okay. So yeah, that's what it is. So when we do 4, again, we're not going to memorize our doubles. We're not going to be like doubles plus 1 because there's no negative doubles if you really think about it. There's only addition doubles. But we don't even want to do that. What we want to do is we want to understand how to add it. So we have 4, and I want to add the 3. When I add the 3, what do? I have the 5. I add the 5, and I take away the 2. So my final answer is 7. See, it's also different because in school, we're always taught to look at the result. We're never taught to look at the add-in. So what I'm trying to do is I'm trying to show, add the 5. Yes, add the 5, subtract the 2. Yes, because what we're trying to do is we're trying to add the 3. Yeah, 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 right? Oh my God, fantastic. So that's what we're doing. I mean, we could do another one, right? We could do another one, which is 2. What do you mean? Well, it's the same thing because 2 also has that same situation, right? So if we want to do 2, I have 4. If I have 4, what do I do? If I have 4, we know how to add the 2. Adding the 2 is what? That is our thing. We're going to add the 2. When we add the 2, 3 plus 2 equals to 5. Whoa, can't do that. 3 plus 2 is equal to 5. We're going to isolate this variable. We're going to make it into 2. Now what do? We subtract. Yes, exactly. We're going to subtract the 3. What we're going to do now is substitute this information. We're going to substitute this into here. So now we're doing a little bit of algebra. Now we're doing a little bit of algebra. We're doing the beginning steps of algebra, right? Because of the constraint, right? This is the constraint. I don't have any more beads. Now we start thinking about critically thinking, how can I do it? Oh, good, Mimi, good. So I add the 5 and I take away the 3. And my final answer is 6. Yeah. See, that's the thing, right? That's why I didn't want to move too fast to go into multiplication and division. What I wanted to do is make sure that we all understand how to add. Because once we understand how to add, right? And it's a step. And then, depending on how big the class is, we can go further or how tired I get. Because when I make mistakes is when I'm tired, and that's when I'm going to have to turn off the live, close my live. But yeah, that's when I know I'm tired, is when I make mistakes, and when they get like big ones. So good. So do we want to do this? Oh, you know what? Okay, you know what? So we get it, right? So now what happens is what? Well, we know how to add. We can subtract. What? Yeah, we know, right? We want to subtract the 2. Right? 2. When we do it, it's 2 minus is equal to minus the 5. Why are we going to do this? How miracles of money? I just purchased. Ooh, what? Nice. Ooh, a wooden one. That's fancy. That's really fancy. So what are we doing here? The reason why we're going to do this is because we have 6 minus 2. That's a very simple question, but we do it so then you can understand, right? This is to help understand what we're trying to do. So when we do 6, I want to take away the 2. Cannot take away the 2. So what do? I know I'm going to minus the 2. To minus the 2, I need to minus the 5. And then what? Hey, Jose, I'm going to add the 3. Now we're doing the opposite. So I'm going to minus the 5. Yes, Dolce. And I'm going to add the 3. So my final answer is 4. So do you see how now we're building and compounding our information? When we look, we've done the plus 4. When we plus the 4, it's plus the 5 minus the 1. Then we have the opposite. We have minus the 4 is equal to minus the 5 plus the 1. Do you see how they're very similar? But commutative property is what Dean was talking about. Now we can do minus the 1 plus the 5. Does it matter? It doesn't matter. It doesn't matter how these two work. It's the same, right? And then this is the same, right? Good, Mimi, good. So now what are we doing? We're just understanding this is how we add the 5. We're only adding the 5. That's all we're doing. And then this is just a little overview of what the 5 looks like. If I want to add the 3 or I want to minus the 3. Do you see how they're very similar? So now what we're doing is we're understanding and we're compounding our information. We're compounding our concept. So as we go through, right, it's exactly the same. Plus the 2 minus the 2, plus the 1 minus the 1. If we know how to add, we will know how to subtract. I know in mainstream math, you add differently than you subtract. But in abacus, it's one of the same. It's parallel. It's complementary. It's the reverse. It's the opposite. Right? So now what happens after this? What happens after this is now what happens when we have no more, when we want to make a 10. What? What does that mean? Well, in school, we're teaching the children how to make a 10. And that's another concept. So it's great that we're teaching the children how to make a 10. And how do we make a 10? We make a 10 by this. I want to do 5 plus 5 is a pair, right? 2 plus 8 is a pair. Thank you for the hearts. 3 plus 3 plus 7 is a pair. 4 plus 6 is a pair. So now what we're doing is we're going to work with the 10. What? So this is another version of carrying the 1, borrowing, trading, grouping, and regrouping. So what's going to happen is, let's do 9. Well, 9 is the same. Let's subtract. Do addition. My question is what? 4 plus 9. So if I add the 4 on my abacus, I want to add the 9. I cannot add the 9. So what are we going to do? We're going to do this not regrouping. We're going to do the carrying on, to carry on. But in abacus, we have this concept. We know this. 1 plus 9 is equal to 10. We have this concept. Let's utilize it. Let's make it for what it is. Let's make it work for us, right? So we know our 9 plus 1 is equal to 10. 10 is this right here. We've seen 10. This is what 10 looks like. Notice it's a 1 and a 0. The 0 is a place value. It's a placeholder. So what that means is if I do 4, right? I'm going to do 4. I'm going to add the 9. To add the 9, it's 9 is equal to plus the 10 minus the 1. Why? Because that's my partner. The 9 has a partner, and the partner is 1. So I'm going to add the 10, and I take away the 1. So my final answer is 13. So what did we just do? We're compounding our knowledge. We understand how to add the 5. Now we're going to do a little bit bigger, which is adding the 10. And once we understand all of this, then you can do any addition, subtraction problem. Does that make sense? We can do another one. We can do 3. So we have 3. I want to add the 9. To add the 9, 13. Yes, Mimi. Yes. The answer is 13. So here, I'm adding 3. And I want to add the 9. Now you're going to see the number pattern. I want to plus the 10, right? Plus the 10, and then take away the 1. When I do that, plus the 10, take away the 1, now I see a number pattern. I need to come to class on time, not in the middle of the lesson. Oh, okay. Oh, Ash, here. No, you got it. So here we go. Let's do a little review on how to read the abacus, right? So we're going to read the abacus. The abacus is a math tool that helps us track our numbers. So Ash, if you're still here, let me know if this is 1, 2, 3, 4. Because this is 4, it's touching the horizontal bar. Because it touches the horizontal bar, we are counting it. None of these beads are touching the horizontal bar, so we're not counting it. So as we go, 4 and then 5. Because this is 5, all the top bead will be a value of 5. So now, if you look, we have 1. Oh, yeah, no, thank you for letting me know. When we have 1 and we want to add the 5, what number is that? That is 6. When we look at 2, we have 2. We add the 5, now we have 7. When we have 3, and we add the 5, now we have 8. And then what do? We have 4, and we add the 5, now we have 9. This will always be 9 no matter what. Just like how this will always be 5 no matter what. So this is 9, this is 9, this is 9, 9, 9, and 9, 9. These are all 9s. Hello, Queen Pineapple. Welcome. Yeah, that's fantastic. So it makes sense, right? So what we're doing is we're just learning how to move the beads. And what this is a formula. So you know a little bit about how to add a 10. So when we look at it, we have 3, we add the 3, and then my formula is here because we're teaching the children how to make a 10. When we teach not a problem, Ash. When we teach the kids how to make a 10, we're going to utilize this. We're going to make our numbers work. We don't want any freeloading numbers. No freeloading numbers. So what does that mean? We want to add the 9. I'm going to plus the 10. Now I have directions. I'm going to plus the 10 and take away the 1. I'm going to plus the 10 and I'm going to take away the 1. That's the direction. So now we're minimizing mental labor. Why? Because it's obvious, right? It's obvious. That's what I want to do. Plus the 10, take away the 1. That's it. There's nothing more to that. There's nothing about beating around the bush. There's nothing. It's just plus the 10 minus 1. And you'll notice when I add the 9, it's this and this. And this will always be the number pattern. So now you're going to see the number pattern. When we do 2, right, we add the 2 and then we add the 9. I don't have enough beads to add the 9. I only have 7, 5, 6, 7. I don't have enough beads to add the 9. What do? Well, I use my formula. Plus the 9 is plus the 10, and I take away the 1. And my final answer is 11. Good. So you start with the smallest number? No. You start with the add-in that you have. It doesn't matter what number it is. It does not matter what number you have at the top. What matters is what the add-in is and what you're trying to do. So there was this one where somebody was mentioning changing out the numbers. You don't need to. Just start with one number. It doesn't matter what number you start. Start with the first number. Yeah, you start with any number. I just happen to have questions like that, right? So we can have, because we're adding a 9, everything to add a 9 will always be less than 9, right? 8, 7, 6, 5, 4, 3, 2, 1. That's all less than 9. So it doesn't matter. But if you're like at 5, it doesn't matter if you're more than 5 or less than 5. So here's the question. So one of my parents were like, well, I want my child to, isn't it the same to know, I should write it out. So one of the questions was like, isn't it the same to do 8 plus 5 and 5 plus 8? I'm like, no, it's not. By the way, I have an IEP, so I'm a little slow. No, you're not. You're fine, Dolce. You're fine. You just let me know if you don't understand. That's all. If you don't understand, let me know, because I'm not going to be able to read your mind. So, Mimi, I have these ones because there's a 5 and then there's a plus 10, and then there's a preschool one. So I don't know if, yeah, see? Kat says the same. You're doing great. So those are the books, and then they're available. If you have TPT, Teachers Pay Teachers, I'm over here. You can get it from my website. It's link in bio, or which one? Or you can find me here. Okay, so I'm gonna do that. All right, no, here. How about that? How about that? There. Yeah. Okay. So the name of the book, this one, that one, or okay, so there's this one, and then then I added these two. Okay, so wait, let's just screenshot that. Right? And then there's this one. There's these two. But if you go to this one, if you go here, you'll see this is my name. That's my name. Hi. Oh, yeah. So what's going to happen is this is first. This is first. This is second. That's second. And then this is third. So that's the order. That's the order. So it'd be something like that. Something like that. There we go. How about that? Is that better? I don't know. Okay. Yeah. No, thank you. I hope it helps. I hope it's entertaining too, Like I want the kids to like have fun. Or even adults. I'm in the middle of making an adult book. But then if you wanted to see, so there's the maze. So this one is a maze for the +5. And then after the maze is what? After the maze there was another one. There was color by number. There's a couple of color by number stuff. And then I try to add in the answers in the back. So I'm hoping that my answers are okay. Let me know if there's a typo. But I try to go through all of the questions to make sure that they're correct. Okay. So, Dolce, let me know. Yeah, let me know, Dolce, if you have any questions and we can reiterate. Because it doesn't make sense for me to keep going if you don't understand it, right? Okay. So one of my parents was like, well, I want them to know this. Well, that's fine. But the problem is now is we know how to add it to 5. How do we know? Well, when we look, we have 8, and then we want to add the 5. Do we remember how to add a 5? We know how to add a 5, right? We know how to add the 5. Do we remember the formula how to make a 5? How to make a 10? Now I'm just cleaning up because I have a lot of props. How do we make a 10? Do we remember how to make a 10? Yes. Add the 10, subtract the 5. Yes, exactly. So what we're going to do is we're going to add the 10, subtract the 5. When we do that, we want to plus the 5 is equal to plus the 10 minus the 5. So what's going to happen is I'm going to minus the 5 and I'm going to plus the 10. When I plus the 10, notice it's a 1 and a 0, 1 and a 0. So when I look, my final answer is 13, which is good, not a problem. But now this is the problem. Why? Because now we're going to talk about it. We're going to add the 5, and now what do we need to do is we need to add the 8. We need to add the 8. We don't have any beads to add the 8. We know that when we add the 8, it is equal to plus the 10 minus the 2. When we plus the 10, let's plus the 10, right? We know how to add the 10. Now what are we going to do? We're going to take away the 2. Whoa. Notice I cannot take away the 2. We know how to take away the 2. How do we know how to take away the 2? What is it that we do to take away the 2? Yes, we want to minus the 5 and add the 3. Exactly. So we want to minus the 5 and then take away the 3. Why am I going to do that? Because I don't have any more beads to take away the 2. So I have to utilize my 5. I'm going to minus the 5 and I'm going to add the 3. So my final answer is 13. So when I talk about it, the answer is the same, but it's how you get there is different. We're all very different in how we get it. It is more difficult that way. It is not difficult, actually. It's a different way. This is going to be very common in other places. This is just an example. So what's going to happen is this is what we call a two-step equation. Why? Because now, and that's why you have to ask these questions, because now this is what made it a two-step, because we need to minus the 2 is equal to minus the 5 plus the 3. It's not a difficult way. There's a lot of two-step equations. It's just another way, and you'll see it. You're going to see it in many other ways. Now it just depends. So what we did is we took our information, and now we're going to Tetris our way through. We will do another. We are going to now Tetris. We have our elements. And now what we're going to do is we're going to Tetris. Does anybody play Tetris? The other one is, wait, how do you use the abacus? Hey, Drippy, Drippy Drip. To use the abacus, before I continue, does anybody know how to use Tetris? Right? Tetris or Blockus or blocks, right? I think it is easy. Yeah, right? So what it is you're trying to figure out ways to, right. Oh, good. Right. Okay, good. So that's what we're doing is we have our blocks, right? We have our blocks, right? And now we're trying to figure out how does it all fit? That's what it is. Yes, Tetris is fun. Okay, so Drippy, we're going to do a little review. What we're going to do is we're going to count on the abacus. To do it, we're going to do 1, 2, 3, 4. All the top beads, all these beads that are touching this horizontal bar is now being counted. So what's going to be, oh, you know what I should do? Maybe I should put like my things in here. Maybe I should do this minus the 5 plus the 3. When we use the abacus, I see your 30 is, does it matter? Yes, it does actually, Ash. So if you notice, I have a ones indicator. This ones indicator tells me that I'm going to start here. I could start here if I wanted to, but I would rather not because I want more digits. I want more place values. If I start here and I move everything over, then I only have ones and tens and I don't have the hundreds. So that's why I would start here. My ones, my tens, my hundreds, my thousands, my 10,000s. Yeah, it is about place value. So then notice that my decimal sits between the ones and the tenths. My decimal sits right here. So I have my tenths and my hundreds. Yeah, thank you for the likes. Does that make sense? Yeah. So I don't know if I mentioned that. Um, so we have 1, 2, 3, 4. Drippy, are you still here? So we're gonna do 5. This will always be the value of 5. Yes, not a problem, Ash. It's good that you have these questions because I don't know what you don't know. Oh, good. So if you have the 5, notice when I add the 1, I'm gonna make this 1. But when I add the 5, now we have 6. We have 2. We've seen this before. We have 2. Now when I add the 5, I have 7. We have 3. When I have 3 and I add the 5, now we have 8. And then we have 4. But then when I add the 5, we have 9. And that's it. That's all it is. So we have 9, 9, 9, 9, 9, and 9, 9. So all of this is 9. So when we look at it with our place value, we have 9, 9, comma, 9, 9, 9, decimal 9, 9. That's all it is. And that's the reading the abacus. That's it. Yeah, I think I'm going to make these little shapes. That's funny. That's so funny. Abacus. You bought this abacus on Amazon? No, I sell this one. I sell this one on my website. But you can buy it on that one. Not a problem. But you know, it depends if you like this one. I think there's a 13. If you like the colors, I think there's a 13 column one with colors. If you like the colors, there's also Daiso. Daiso. I don't know if you have Daiso, but Daiso also sells the 13 column one. This one, and then some people were able to buy it for less than $4. So if you add the 5 to the 10, ooh, yeah, that's a good one. So if I add the 5, that'd be 50 cents because it's a 0 and then 5. That's what it would be. It'd be 50. 0.5. It would be 0.5. That's what it would be, right? If we were talking about number, it'd be 50 cents, right? This would be 51, 52, 53, 54, 55. 56, 57, 58, 59, and then 60 cents. Yep, that's what it would be. Exactly. So, Mimi, yeah, I don't know if you have a Daiso around you, but you can get this one from a Daiso. This one you can get, yeah, you can get that over there. Yep, 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 yep. Oh, you might be able to find it in the TikTok shop. In the tens place is 50. Yes, exactly. So if we have the tens place, right, we have our ones, we have our tens. That would be 50. Yeah, I know some TikTok people are selling the abacus as well. I don't know if you want to do that. It's up to you. I don't know if they're on sale or whatever, but I do know that they're available, and they're all the same. They're all the same because what it is it's very easy. It's not. I mean, they're all the same. I haven't had one that has been really bad, if that makes sense. Yeah. So if we did this one, this would be 500. Right? Because it's at the hundreds. And if I did this one, it'd be 5,000. And I did this one, this would be 50,000. Thank you for the likes. Yeah. Yeah, that's a good question. Okay. Are we okay? So we're going to continue on with our two-step equation. What video did I miss? What video did I miss? I don't know what video you missed. All right. So we're going to do a couple more two steps. Why? Because two steps is really interesting. The reason why we want it, because we want to solidify our concepts of adding the 5 and adding the 10. So what we're going to do is we'll do this number, right? We do 49 plus 3. Now, why is this a two-step? Well, if you look, this is more than a two-step because we have 4 and we have 9. Now what are we going to do? Notice, but see, the thing is now we have to critically think, what are we trying to do? we're trying to add the 3 here. We're trying to add the 3 here. If this is too much, what we do is we do this. Sometimes that's helpful, right? We're trying to add 3 to this. What is the formula to add 3? Plus 3. Here's a question. Can I add the 5? No, I cannot add the 5. So I cannot use a 5. I need to plus the 10 minus the 7. That's what I need to do. So what's going to happen is I need to plus the 10. Yeah, that's a trick question. No, not a minus the 3. Not a minus the 3. Because we want to add. When we add, we don't want to minus the 5. We're going to add the 10, right? And minus the 7. So before I do that, okay, so what do? We add the 3. But then let's do it different because I'm not going to remember this. What we could do is minus the 7 plus the 10. We can do that. Oh my God, this is easy. This is an easy. Schools should teach the abacus instead of letting them use calculators. I appreciate that comment. Yes, thank you. So before I move forward, right, Kat, before I move forward, I'm going to minus the 7 first. So I'm going to minus the 7, and then I'm going to carry the 1. When I carry the 1, can I do it? No, I can't. I cannot carry the 1. So what am I going to do? I need to plus the 5 minus the 4. So now, oh, sorry, you can't see that. So what I'm going to do is I'm going to plus the 5, and I'm going to take away the 4. And my final answer is 52. The reason why we do this is the two-step equation, but it's helpful to know those questions you're asking. Can I add? If not, how? Those are the biggest questions. Thank you, Drippy. I do appreciate that. Some people are like, it still rings in my head. Some people are like, you're making it more complicated than it is. Why? Oh, yeah, So this is what we call commutative property. That's what I was explaining from before, right? We can do either or. Yes, we'll do it again. We'll do it again. We will do it again. So if you notice, we could do this. Minus the 10 or plus the. This is what we call commutative property. This is a math terminology. The commutative property is the addition states that changes the order of the numbers being added. It doesn't change the sum. So the reason why is because I don't want to have to forget. So when we did it, we did 40, we did 9, right? We did 49. And notice we can plus the 10 and then, nope, I'm on the wrong side. Sorry. We'll do this one. Plus the 10, take away the 7. Plus the 10, take away the 7. But the thing is I don't want to forget to take away the 7. So what I could do is I could do it this way first. I could take away the 7 first. So I can do minus the 7 plus the 10. So it's just whatever is easiest for you, right? I want to take away the 7 first so I don't forget. And now I'm going to plus the 10. Notice when I plus the 1, right? I'm going to carry the 1. As I carry the 1, I can't do it. I can't carry the 1. What do? I need to carry the 1. To add the 1, it's plus the 5 minus the 4. Now I want to plus the 5, and I take away the 4. Yeah. So what we're doing is we're changing the numbers, we're changing the equations to whatever makes sense to us. We're not always going to be doing it this way. We want to make it where it makes sense. So my final answer is 52. Can the abacus also do multiplication and division? Yes. Nail Mango? Yes. Oh, good, Mimi. Yes. We can do multiplication and division. But I wanted to make sure that we understand our two-step because I don't want to, because that's one of the things to really solidify, right? To really solidify our, oh, okay, hold on. I'll be right there. To really solidify our formulas. And these are concepts that we are teaching the children. So what we're doing is the abacus takes this information and we level it up. Okay, Bambi, what we're going to do is we're going to read the abacus first. So the first thing we're going to do is we're going to understand how to read the abacus. This is 1. This is 2. Anytime that the beads are touching the horizontal bar, we're counting it. This is 2. This is 3. After 3 is 4. After 4, right? This is 4. None of these beads are touching. These are 0. I need to attend this class more often. So then after 4, right, we have 0. This is all 0. After 0, this is 0. What's going to happen? This is 5. This will always be 5 no matter what. The top bead will always be 5 no matter what. You guys are so funny. So after 5, right, Bambi? Are we okay? Do we understand that? After 5, notice I want to do 1. We know what 1 looks like. Guess what? When we add the 5, now we have 6. Bro, I'm saying I'm laughing so hard how much I'm learning. Sorry, Bambi. So we do 2. We know 2. We know what 2 looks like. We add the 5, we have 7. Whoever made the abacus, I know, right? Like it's really quite elegant, especially when there's like the indicators. It's pretty impressive. And then the concepts to like manipulate for the different numbers. So I'm sorry, Bambi, we have 3. When we have 3, we add the 5. Now we have 8. And then there's again, if I have 4, I know 4, and I add the 5, now I have 9. So now the question is why are we here? The reason why we're here is because I have this dot. This is my ones indicator. Now I'm at place values. So we have our ones, our tens, our hundreds, our thousands, and our 10,000. And as we look, we have our decimal. Our decimal sits between our ones and our tenths. And then we have our decimal. So it'd be like money, right? 10 cents, 20 cents, 30 cents, 40 cents, 50 cents. 51, 52, 53, 54. Does that make sense, Bambi? Thank you so much for sharing my live, Mango. Yeah, it's really quite elegant. So then when we look at it, these are all going to be 9. This 9, this 9, 9, 9, 9, 9. So, Bambi, are you still here? Because if you're not, then I'm going to continue on. We're going to do multiplication. Oh, good, you're still here. Okay, good. So what's going to happen is, and that's what we're doing, is we're reading the abacus. But what happened after the abacus is reading the abacus, we understand how to move the numbers. So when we move the numbers, we have 2 plus 2. Great. So now the difference is we move the numbers. We have formulas to move the numbers. As we move the numbers, all we got to do is figure out how to read it. You actually do the excuse me, you actually do the calculations in your head. If the abacus just helps minimizes mental labor. So okay, so we understood that this is 9. So this is 9, and then this would be 39. And so what we did here, we did 49. So what this is an example of a two-step equation. A two-step equation meaning is what we kind of talked about earlier, is that there's these concepts that we're teaching the children. We're teaching the children these concepts, but that's as far as it goes. Whereas in abacus, we actually take it one step further. We actually level them up because we make our I feel like an abacus is more literal. Yes. Yes, it is. It is very literal. It mimics the way we write. And we'll talk about that when we do multiplication and division. No, yeah, that makes a lot of sense. Mrs. My own woman. No. Oh, thank you for the follow, Drippy. So what are we trying to do? We're trying to utilize this concept. This concept is being taught in kids, which is fine. But then what abacus does is we level it up a little bit. We level it up, and that's what these formulas are. We call them formulas in the abacus world. We call them formulas. I think in the mainstream we would call them expressions. And so if you look right, this is very similar to algebra. And so this is. Thank you for the follow. So what's going to happen is when we do. What am I doing? Let's do this. So when we do 1 plus 4 is equal to 5, if I wanted to isolate this 1, notice that I'm going to do x is equal to, x plus 1 is equal to 4. I'm sorry, x plus 4 is equal to 5. So now we're starting the beginning parts of algebra, but the kids don't know it. It was really strange. My son, he learned the abacus, and when he went into algebra, he's like, I was never taught algebra, but this, I know how to do this. And it's like, it's because we actually do this in abacus. We never labeled it. So if I need to isolate this variable, what am I going to do? I'm going to take this and I'm going to move this over here. So what I'm going to do is x is equal to 5 minus 4. What? Yeah, so what we did is we started learning the early parts of algebra. So you can't tell me that you don't like algebra because abacus is a little bit of algebra. Right? Right? Yeah. So yeah, a lot of what we're doing is very much algebraic, right? So then let's say we have this number, right? We're going to substitute, right? That's what we did. We substituted this information to here. That's an algebra thing. Substitution is algebra. Thank you for the follow. Right? Makes sense. So that's what I'm saying is like when we start learning abacus, we're starting to see more algebra. Yeah. See, the thing is you know it, but it wasn't obvious, right? Hi, welcome back. So that's what we're trying to do is I'm trying to show how obvious it is. And so like this, right? What we did is we substituted this information into here. That's why it's called a two-step. But it's all about substitution and how it all Tetris's way through, right? How does it all fit? But that's the thing. You know this. You know how to do all of this. You will know how to add and subtract hands down. No matter what. Doesn't matter how big the number is. This learning how to make a 10, learning how to make a 5, everything is all about that. Substituting the function is using it visually in abacus. Yes, exactly. Exactly. And on the abacus, it gives you direction. Thank you for the follow, Mango. Right? It gives you directions. So all you got to do is follow the directions. It's quite obvious. Yes, indestructible. Welcome. Welcome. Thank you guys so much for liking the live. But does that make sense? So that's the thing. Like, and that's what I try to do is I try to explain. I mean, everybody wants to go forward, even if it's a huge number. You know what? Give me a number. Give me a number. Let's do it. But you know what? I will give you the caveat. There might be a lot of what do you call it? Like two-step equations. Well, let's take it slow. Let me see if I can find a number. Or you can give me numbers. Okay, good. Thank you. Because I don't want to think. Okay, let's take it slow. Let's do 1046 plus 267. All right, good. What are we going to do? How are we going to do it? On the abacus. Okay, the first thing we're going to do is we're going to do the first line, right? To do the first line, what are we doing? 1046. Notice, I know it's 1000. I go straight to here, 1000, right? 1046. When we do it, what we're going to do is we are always going to start from left to right. So we start from left and then we go this way. So I add my 2 because I have the 2. Now I have 6. Can I add the 6? No, I cannot add 6. What do I do? Plus the 6 is equal to plus the 10 minus the 4. So I'm going to plus the 10 and minus the 4. Plus the 10, take away the 4. And now I'm here at the 7. So plus the 7 is equal to plus the 10 minus 3. So I'm going to plus the 10. I'm going to minus the 3. Can't minus the 3. What do I do? I know how to minus the 3. Do you know how to minus the 3? I know how to minus the 3. Minus the 3 is equal to minus the 5 plus the 2. Minus the 3 is equal to minus the 5 plus the 2. Yes! Thank you, Kat. Yes, exactly. See? It all fits together. It doesn't even matter how big it is. It doesn't matter. It doesn't matter how big the number is. You know these ones down pat. You know everything. That's why it's fun. Adding the 10 is just moving one bit over. Yes, carrying the 1. Yes, because if you notice the 10 is just a 0 placement. Yeah, that was fast. Yeah, so if you notice the 10, this 0 is a placeholder. This placeholder sits right here. Remember when I was reading the 10, right? We do 1, 2, 3, 4, 1, 10. The 10 is just the carryover. I get it. It's very easy. It is very easy. But see, you have to lay the foundation before you go through it. And then you know the questions to ask, right? These are all specific questions that I'm asking, right? So when you have specific questions, does that make sense, Ashloy? Did that make sense? So you're right. When we want to add the 1, right, or we carry the 1, it's all about carrying the 1 and subtracting the 1. That's all it is. That's all it is. You're just adding the 10, taking away the 10, no matter what. We can do a better one. We can do a better one. This is the one I like the most. What do I mean? Okay, so let's do 9999 plus 4. No, thank you for the question. What? That's a big number. No, it's actually quite fun, right? We have 4, 99999, right? We want to add the 4. We want to add the 4. Can we add the 4? No, we can't add the 4. Can we add the 5? No, we can't add the 5. What is our formula for adding the 4? What? Plus the 4 is equal to minus the 6 plus the 10. Exactly. So what are we going to do? Oh, I can't see it. We're going to minus the 6 plus the 10. So I'm going to minus the 6. I can't see it. Minus the 6. We're going to minus the 6. And then what are we going to do? We're going to plus the 10. We're going to plus the 1. We're going to carry the 1. We're going to plus the 1. Can I do it? No. What do I do? Plus the 1 is equal to what? Minus the 9 plus the 10. Why? Because I cannot use the 5, right? I cannot add the 5. So I need to plus the 10. I'm going to minus the 9 plus the 10. Minus the 9 plus the 10. I'm going to carry the 1 over. Can't do it again. I got to do it again. Minus the 9, carry the 1. Can I do it? No, I can't do it. Minus the 9, carry the 1. Can I carry the 1 here? Yes, I can do it. I can add the 1. And that's my answer. 10,003. Once you can do the adding of the 10, then you're done. 10003. Yeah, I really like this number. The reason why is because it's fun. It's fun because you get the numbers again. Right? Even easier than on paper. Yes, exactly. It's all about the questions too, right? So that's the difference between new math and abacus. New math, you do it on paper. In abacus, you do it on the abacus. Of course, we could do another one. Oh, you know what? This will be my last one because it's going to be, it's time for dinner. Do you want to give me a number? Give me a number and I'll help you and we'll work it through. Give me a number. What number do you want to do? Yeah. Let me know what number you want. I don't know if that was too much. I love your life. Hey, probably AFK. Welcome back. Thank you. Okay, good. Okay, good, Dolce. Let's see. We do. Okay, we'll do 2. And that would be that. Then that would be it. 4, 5, 6 plus 3, 2, 5. It's so cool seeing all sorts of different ways people can solve. Yeah, yeah, it's really interesting how everybody does different things. So yeah, I mean, like they can do like blocks and strings and stuff, and I don't do it that way. I only teach the abacus, so that's what I'm trying to do. I'm just trying to show how to use the abacus. And we do 4, 5, 6. Oh, I need to do is before I forget. We need to do 24, 5, 5, 1, 3, 0. Yeah. So if the top beads is 5, the bottom beads are 1. Yes, exactly. How do you do 7 minus 3? 7 minus 3 is different because now we're dealing with how to make a 5. So before I continue, yeah, that makes sense. So we have 7 minus 3. So I have my number, I have 7, and I want to take away the 3. When I take away the 3, we know how to make a 5. The reason why is because we want to be able to utilize the 5. When we utilize the 5, we have a minus the 3 is equal to minus the 5. Notice this is not balanced, so we're going to have to add the 2. So what we're going to do is minus the 5, and now we have directions. We minus the 5, and we add the 2. So my final answer is 4. Did that make sense? So there's two sets of formulas that we need to understand. There's making of the 5 and making of the 10. Yeah, that's a good question. That's a very good question. Okay, so we have this. We have 4, 5, 6 plus the 3. Oh, sorry, you can't see that. Plus the 3. When we add the 3, what are we going to do? Let's do purple. Let's do purple. So we add the 3. Can we add the 3? No, we can't. So what do? Can we add the 5? Yes, we can. So just as we did here, but now we have to do the reverse. Thank you, Mimi. Yes. So now we do the reverse. Plus the 3 is equal to plus the 5 minus 2. So we just built our information, right? So we have plus the 5, take away the 2. And then here, we want to add 2. Can we add the 2? Yes, we can. Just like Bob the Builder, right? Can we do it? Yes, we can. So we're going to add the 2. And then we add the 5. When we add the 5, can we add the 5? No. We cannot add the 5. What do? We have to plus the 5 is equal to plus the 10 minus 5. So I'm going to plus the 10, and I take away the 5. So my final answer is 7, 8, 1. Let's do the final one, and then I'm going to sign off. Yeah? So we have 2,455. Now what do? Right? We have 1. Do we have enough beads to add the 1? No, we don't have enough beads to add the 1. What do? We know when we add the 1, can we add the 5? Yes, yes we can. To add the 1 is equal to plus the 5 minus 4. So I plus the 5 and I take away the 4. Ah, this is so easy. This is easy. Come on. So what do? We have to add the 3. Is there enough to add the 3? Yes, we can do it. We can be Bob. And Bob the Builder says, yes, we can. I'll be back. Oh, good, Ash. Woo. Woo. Does that make sense? So our final answer is 2, 5, 8, 5. That was too easy, Mimi. Right? Was it Mimi that? Yeah, Mimi. That was too easy. Yeah. So, I mean, all the biggest questions are, can we do it? Yes, we can. If not, how do we do it? I love your energy. Oh, thank you. Thank you, Mango. It's fun when people get it, right? I'll be back to multiplication division. Yeah, not a problem. Not a problem. I It depends. Honestly, it depends on how quickly the class can go, and it depends on how much energy I got. Yeah, not a problem, Ash. Thank you for the questions. I do appreciate all the questions, And especially since you guys, want to make sure, I want to make sure everybody understands. I still don't get addition, but maybe tomorrow. I still don't get addition, maybe tomorrow. Okay, not a problem. Have a good night. Have a good night, Dolce. Thank you. You know what? We will keep practicing, right? We will keep practicing in the beginning to add. And as we add, you'll see it. It just takes time. That's all it does. It takes time because it's something different. Yes, thank you, Mango. Yes, Mimi. Have a good night. Have a good night. Oh, thank you. Hey, Jay, welcome back. I didn't know you were here. But I was going to sign off. But yeah, Dolce, it's a different way of thinking. So don't pressure yourself that you're not getting it. It takes time. It took me time too. I just came in. Ah, nuts. It's morning for you. Oh, I don't know. Did I tell you? Hey, welcome back. I was about to head out actually. I don't know, Lady J, if I told you about my new maze. I'm trying to get it to be published. So I got the -2. I got the 2 digits, and then I'm going to work on 3 digits as a maze. And this is just about bead recognition. Yeah. Ah, okay. Yeah, and maybe we'll see you tonight. Hello, coalition. I'm gonna head out though. I am gonna head out. I guess this is when everybody comes in. I love it. Oh yeah, that's great. I'm putting it on the other one. I'm putting it on Amazon. So right now it's going through review, and then you'll be able to see it. But yeah, it's a 2 digit, and then there'll be a 3 digit, and then I don't know. I also added a mask maze, so you can't cheat. So I have it where you can print it out, and then you can just like um yeah, and then hide the answers. Yeah. Hey Ronnie, thank you. Thank you. I appreciate that. But I am signing off. I do apologize for everybody joining in. I am signing off. That's great. Thank you so much. Yeah, I'm trying to build out more books and stuff. So I'm on to 7, 8. I'm on my 8th book. Thank you. I'm on my 8th book, and so I have a few more that I need to publish out, and then hopefully I can flood the market with abacus. That's the point. The whole goal is to flood the market with abacus. Makes you make me want to learn more. Oh yeah, me. Thank you, thank you, thank you. I appreciate that. I do appreciate it because I think it's fun. I think it's fun, and I think it also keeps the mind active. What they call it, mental. I'm on day 4. I'm on day 4. Really? Wait, day 4 for what? Why can't you be my teacher? Ah, Ronnie, I'm sorry. Videos. Oh, I got it. You know, I'm gonna redo those videos. I gotta redo those videos because that was before I started all my TikTok lives. I get your emails. Oh, okay, good. Tomorrow I'm gonna have an official what do you call it? Official meeting for my students and anybody else on TikTok. Not TikTok, on YouTube. And so those are for my students. But I do come on TikTok. Do you go live every day? I do go live every day, but it kind of switches out. So I think put in the notifications so you can get notified whenever I come on. But I do try to go twice. Sometimes if I have enough energy, I'll do 3 times, and then I have my books. But I'm trying to build out my books, and so I can flood the market. Oh, before I forget, if you want this chart, I have this chart available in my bio if you want it. All you got to do is just sign up, and then I have this chart, and I can give this to you. This is a download. It's a download. It's a free download, and I think I go up to 12. I'm not sure. Yeah, not a problem, Dean. I'm actually gonna head out, because I'm gonna go get dinner. My husband made some dinner, and so I'm just gonna go and have some dinner. So yeah, not a problem. I'll probably be on, depending on my energy. I'll probably be on later tonight, but we'll see. We'll see. But yeah, Mimi, if you want, you can have this for. Oh yeah, Dolce. If you want this, I don't know if you have it. You can go to my link in my bio and get it. It's called Intro to Abacus, I believe. Yeah, and you can get this, and it shows you how to read the abacus. let me know if you have any questions. It's amazing. I'll see you whenever you're back on. Yeah, yeah. You know I'm on pretty often, right? So yeah, yeah. Just so you know, this is free. Enjoy your dinner. Excellent. Thank you. Oh, thank you so much, Lady J. I do appreciate that. I try to be entertaining. Okay. Have a good night, everybody, and I will see you guys in my next live. Bye.